The sample space are all possible outcomes. So when we talk about a coin toss, what are all your options you could possibly get when you flip a coin? Heads or tails? Heads, tails. Normally we just abbreviate that H and T. Okay, so heads and tails would be your sample space. What about a dice? What are all the possible things you can get out of rolling a dice? 1, 2, 3, 4, 5, and 6. There's your sample space. Okay, what about a letter grade? A, B, C, D, and F. There's your sample space. So again, these are all pretty simple events. It's talking about one object. We're going to work our way to more than one object as we go through this unit. Okay, but sample space is just what can come out of your event happening. And the event is the actual rolling of the dice or the flipping of the coin. So when we talk about probability, it's a fraction. Usually we hear them as percents, and that's just because they've converted their fraction to a percent. On the bottom are the number of all possible outcomes. That's where knowing your sample space comes in handy. Is if we know all the possible outcomes, then we can count them and figure out how many there are. Ryan, you need to finish your test before you start this. Then go ahead and turn it in. On top, the number of ways what you want can happen. So when I asked earlier, what's the probability that you roll a 2 on a dice? Well, how many ways can you roll a 2? 1. How many total ways can you roll a dice? How many outcomes? 6. So 1 over 6. But this is the basic idea. Now how probability can get a little more complicated or a little harder is when the number of ways something can happen is not so simple as just 1 way or 2 ways. It's not as easy to count. Same thing with your number of all possible outcomes. It's sometimes not as easy to just figure out 6 or 2 or 5. But like I said, we're going to work our way up to that. But everything about probability comes back to this basic fraction. So we're going to just practice finding some probabilities today. So we're going to find 5 probabilities. The first one is, what's the probability of rolling an odd number on a dice? So think about all the outcomes you have on a dice. How many of them are odd? 3. So we have 3 possible odd outcomes. How many total outcomes did we have? And then you reduce it. Your probability is 1/2. If you want to write it as the fraction 0.5, you can. Okay? Those are going to be our 2 acceptable forms today. Either reduced fraction or a decimal. Okay, what about the probability of heads on a coin toss? So rather than writing out all of our words like this, sometimes you'll just see a P and then in parentheses is what you're looking for. So what's the probability of heads on a coin toss? So how many ways can you get a heads? 1. How many total things could you get when you flip a coin? So 1/2. And again, if you want, you can write that as 0.5. What about 3, the probability of a passing grade? Okay, so what's passing? ABC. So that's 3 out of how many total grades could you get? 5, so it's 3/5, or again, if you change that to a fraction or a decimal, It'd be a 0.6 chance or probability that you get a passing grade. Okay. What about the probability that we roll a number greater than 6 on a dice? 0? Is there any number greater than 6 when you roll a dice? No. It didn't say greater than or equal to. It just said greater than. So there's no way out of the total of 6 that we have. So this would be an example of something that has no chance of happening. What about a probability that we roll a number less than 10? Okay, all 6 of the outcomes possible are less than 10. So you have a 1 as your probability. 0 and 1 are the range of your probability. So all probabilities are going to never go lower than 0, and they're never going to go higher than 1. Because 1, if you convert it to a percent, is what? Anyone? 100%. You can't have a probability over 100%. So we say all of our probabilities are going to be fractions or decimals between 0 and 1. The closer to 1 you get, it's going to be more likely to happen. Or your probability is going to be higher or more likely to happen. Closer to 0, less likely it's going to happen. Okay?
I don't get number 5.
Okay. So on a dice, what numbers do you have? 1, 2, 3, 4, 5, 6. So if we're looking for the probability that when we roll the dice, we get a number that's less than 10. So we have a total of 6, so that means our denominator is 6. Now how many of these fit that condition, less than 10? All of them. So that's why it's 6 over 6. Okay, any questions so far on just basic probability? Okay, this is all we're going to do today. The second half of this, have you guys heard of Venn diagrams before? The second half is applying probability in image form with Venn diagrams and two-way tables. That's the second half of 14.1. We're going to do that Monday because it gets to be too long to do today. Okay? So your only assignment is numbers 1 and 2 on 14.1.